At this time, I'd like to introduce you to today's speaker, Lee Barnes, the founder and CTO of Utopia Solutions. Good morning, Lee.
All right, hello everyone. I certainly don't believe in best practices. I do believe in guidelines and better approaches for a solution. Best practices says to me there's only one right way of doing things, and that's just a little bit crazy with the variation in technologies and approaches and systems that we have today. So what I want everyone to do is take away the practices and the approaches and techniques that we're going to talk about today, and apply them to your work. Certainly challenge them and understand how to make what you're doing a little bit better. So let's move on to the key questions that we want to answer today. Certainly, we need to understand why mobile app performance is important. And if we can all agree that it is, we need to understand how it's different from the way that we test our traditional applications today from a performance perspective. And finally, we need to take those differences and really understand how we can adapt our practices. So let's take a look at why mobile app performance testing is important. This is a bit of a dated statistic. It's actually a little bit more dramatic today. But if you look at mobile commerce, over 60% of shoppers abandon their transactions, and half of those abandonments are reported to be because of poor performance. All right, so if you're not delivering the content that your users are looking for in the time they're looking for it, they're going to find another avenue to get what they're after. And I think we've probably all seen this. A second delay equals about a 7% drop in conversions. Obviously, this is specific to e-commerce, but certainly there are other performance is important in other types of applications in other industries. Right? We've all been at a stoplight and trying to get directions before the light green, or maybe in a checkout line and trying to get that coupon up before it's our turn. You would, even though mobile applications have less resources available to them, the expectations of the users are that it's going to be at least as fast, at least as responsive, if not more so. And if you think about that for a second, it's really the context of the mobile users themselves. They're on the go. They're mobile, right? And they're likely in a situation where they need to use your application and and the data that it offers as quickly as possible. And if we still don't think that it's important, we can look at last year's World Quality Report, and for the last few years now, efficiency and performance have been the top issues that IT organizations have been looking at from a testing perspective. So it's definitely on everyone else's mind, and it needs to be on our mind as well. So before we look at specific challenges to mobile performance testing, I want to take a little walk down memory lane and take a look to how we got to where we are. And really the main theme here is we've been changing and reacting to change as performance testers for a long time now. Mobile is just that next thing that we're trying to figure out on how to best attack. Back 20 or so years ago, we had two-tier client server. We had some tools that were just starting to come around, not very mature. The biggest challenge we had was that those proprietary protocols that those tools or those applications used, and we really didn't have any skilled resources that were dedicated to performance testing and performance engineering. As the web came about in the next decade, systems got larger, more complex. The types of loads we needed to put in those systems grew. Certainly the tools matured, and we responded as well by having specialized resources. As those required loads got even larger, we saw the advent of cloud-based testing to distribute large, massive loads geographically. And now we have mobile. So what we want to do is understand what's different about mobile. And I think as we'll see, there's some very important differences. But there's also quite a bit that is the same to what we've been doing recently in performance testing. The first thing I want to look at is that your users have options. Right? There's multiple channels that your users can use to access your system. There may be a native app, there may be a native app and a mobile site, and then of course they have the full or responsive site. And the way the users impact your system from a load and performance perspective can vary across those channels, and you need to understand that that's an impact. And we'll talk a little bit more about that a little bit down the road. So one thing we always do as performance testers is assess the user and load profile. We need to understand what the parameters of our test are going to be. And while we could probably have an entire talk on just putting together a good user and load profile and getting those test parameters correct, I really just want to focus on three that are specific to mobile. So we need to understand how those users are coming in to the system. Are the mobile users using a native app, a mobile site, or the full site on a mobile device, or maybe all three? What's their preferred browser, and what are the network conditions? And those three are typically the biggest differences from the mobile profile that you want to look at for mobile. Most importantly, though, and this is nothing new to performance testers, you want to incorporate constant feedback from your monitoring solutions, from your application logs, so you're tweaking the user and load profile to reflect reality and to keep up with the way that user and load profile is changing and changing over time. As a performance tester, my favorite thing is to find out that there's a real user monitoring solution in place that's telling me exactly how the users are using the site and in what volumes. Moving on, and this is probably one of the biggest differences, is the network. Right? We need to understand that a mobile user is not a connected user. We may have mobile users over a Wi-Fi connection, over a 3G, 4G, or of course we may have a poor connection, right? And the best 4G LTE connection in the world doesn't mean a thing if you're in a tunnel. And certainly your network connection will affect both the end user experience and the system load that user puts on the system. Slower connections or slower network connections hold system connections longer. They end up using more resources per user than a user doing a similar piece of functionality over a traditional web connection. All right, and that in extreme cases, right, an additional 10% of mobile users with those slow connections can exhaust the available resources of the system. And if you didn't take into account the network variation, you would miss that completely. I want to take a look at how we can adapt to that. And in most cases, what we're looking at is a network virtualization solution where we are simulating the network conditions that those mobile users would experience. What we'd like to typically do first is assess the baseline performance under these network conditions. So just a single user, observe that user experience over real devices behind a network virtualization solution, so you can see what the baseline performance is over varying network conditions. And given what I just said about the fact that users coming over slower, degraded networks can impact the back-end system as well, when you do put the system under load, you would like your majority of your load, if not all of your load, to go through a network virtualization solution as well. And then to understand what the impact of that load is, again, on the end user, a handful of real devices that, again, are behind a network virtualization solution to measure the user experience while under load. There's quite a few network virtualization tools available. I just want to quickly, this is more for reference after the fact, and the slides will be available for download to everyone that attended. For a single user, either device or emulator, right, the iOS, Android development environments have network virtualization functionality embedded within them. I think, in fact, that screenshot is from the, maybe a little bit dated, but from the iOS development environment. Charles Proxy is an open source solution that you can use to run your traffic through and vary the network conditions. And from a commercial perspective, HP Shunra network virtualization solution has very advanced capabilities to emulate varying network conditions. For putting multiple users or your load behind network virtualization, again, HP's network virtualization solution does a good job. A lot of the load test tools that we use every day have some capabilities to vary the network condition, and again, you can use Charles Proxy to run the traffic from your load generators through Charles Proxy and vary the network conditions. Moving on to another challenge that's typical for performance testing mobile applications is user location and volume. Again, your users are mobile, especially for consumer-facing apps. They're likely to be geographically dispersed and in high volumes. That becomes very difficult to reproduce in a lab. And for those of us that have been involved in performance testing for a long time, we all started in the lab, right? Maybe with a few dozen, few hundred, even maybe a few thousand concurrent users. But the load generators were in our lab, the system under test was in the lab, and that was great from a scientific perspective. But now with these systems kind of out in the wild, we need a better solution. If nothing from the perspective of simulating tens of thousands of users inside a lab is extremely expensive. So what we typically do is apply a cloud-based testing solution. Something like SOSTA Cloud Test, and there's some other services out there that are available. It allows us to achieve production level loads without having an entire room full of load generators. And just as important, it allows us to test that entire infrastructure versus, again, in the lab and behind that firewall. So we're testing the exact same infrastructure and topology that your users are going to, again, out in the wild. We can distribute load geographically, right? There's cloud-based servers all over the world. Most of the cloud-based service providers have integrations with various cloud providers, and you can spin up a server virtually anywhere you need one these days. Again, though, while we are putting the load on the system, we still want to measure the user experience on real devices. So we will still have devices in our lab executing those same transactions while the system is under load, so we can understand the impact from a user perspective. Finally, from a test tool perspective, I do want to touch on briefly some of the differences that we'll see when we're actually creating the test scripts and executing the load. And there's really three main differences that we found. Capturing the mobile traffic, emulating the network, we talked about the need for that quite a bit, and then also varying the user agent. Everything else is generally the same as desktop web performance testing. Let's take a quick look at capturing the traffic. Most of the tools approach this challenge exactly the same way. They record it through a proxy. Right? In most cases, we can't record from the mobile device. We can't install our tool on the mobile device. So we point the traffic that's coming out of the device through a proxy machine where our load test software is running, and then we can capture that traffic that way. And then, of course, just like we're used to, we can manipulate that traffic to better represent real users. We can parameterize data, we can vary timing, etc. Moving on to network emulation parameters. Again, we have different groups of users coming from different types of network conditions, and most tools will provide these capabilities. We want to map those settings to groups of users, so we can control large amounts of users who are coming over 3G or 4G or Wi-Fi or some type of degraded network condition. We can control them as part of a large group. For the most case, or in most cases, the predefined settings that come with the tools are sufficient. Right? We can get really crazy and try to emulate very, very specific conditions. But the reality is we're kind of looking for the average in terms of being able to put load on the system over these virtualized network conditions. So typically the predefined settings are sufficient in terms of the network quality. If we're looking for the ideal capabilities in a performance test tool with respect to network emulation, like I just said, predefined settings for common profiles, so you don't have to manually configure the bandwidth and the latency and the packet loss. The predefined settings are there for you. Again, the ability to vary the bandwidth, latency, and packet loss across those common settings. And the ability to have multiple profiles per load generator. So if you had a large number of user groups, it doesn't require one load generator per group. And most tools do have that capability. Finally, specifying the user agent. This is the caveat here is if you can understand from your development group how your system varies depending on how the users are accessing the system, depending on the type of device, the type of application, native, full site, mobile optimized site. A lot of systems these days you'll be executing a different code base depending on how you're accessing the system. So it's important to understand, A, if that's the case, and if it is, what the variances are, so you can get the appropriate level of granularity in your different user groups. Again, most tools have predefined settings for the types of devices and the browsers available, and in most cases those will map to your user profile, unless you've just got some situation that doesn't fit the norm, it's typical, and then again, most tools will allow you to customize your user agent as appropriate. One of the last challenges I want to talk about is device performance itself. As performance testers, especially ones that go back a ways, there was a time when we completely ignored the client portion of the response time or the performance of the client itself. We assumed the client was very thin, and we just ignored that time in the browser. And it wasn't such a bad assumption, right? We had essentially unlimited resources in terms of power, in terms of bandwidth, in terms of CPU and memory, and it just wasn't a bad assumption. compared to the level of effort to try to understand what that of the performance puzzle was. But obviously, mobile devices do have limits around CPU, around memory. The battery has a limited life, a limited amount of storage as well. So we need to understand, from a device perspective, how our application impacts that device. Typically, from a metrics perspective, and what we want to understand about our application is how does it impact CPU, memory, battery usage, and storage, if that's something that your application does. We want to capture those metrics while we're exercising the app. We want to make sure that we're including the appropriate devices and configurations that map to our user profile. And we like to use automation for consistency, so we can run the same set of tests over multiple configurations and then compare the results and know that the steps and the way we exercise the app had minimal variability in our, or added minimal variability to our results. And there's, again, a lot of technology out there to help us capture that. Again, the mobile development platforms have that built in. Automation tools, Appium, touch tests from SOSTA, Trust for Mobile Apps are a handful of examples of mobile test automation tools that allow us to capture those metrics. And then if we're using our devices inside of a mobile lab or cloud solutions, they have those capabilities as well for the most part. The process we like to use to understand the impact of the application on the device is first just gather metrics from the device only. So, a fresh start, only the processes that are there on startup, and we understand kind of the idle metrics of the device itself. Then we'll open up common background apps that are likely to be open while our application is being used, and we'll understand how that impacts that or changes from that baseline measurement we just took. Then we'll open up our app, and we'll typically take some measurements while the app is backgrounded. So, what is the impact on the device while the application is open, but not necessarily being exercised? And then finally, we'll take another set of measurements, again, ideally using an automated test for consistency, and we'd exercise the target app over just some basic usage scenarios, so we can measure the differences again against our baseline results. And this gives us a good idea of how our application is going to impact not only the performance of the device, but also other applications on the device. An extreme example, right? If the application cuts battery life in half, that severely limits the usefulness of the device and any other apps that are on it. From a device measurement perspective, certainly one thing we've learned over the years is to start early. As soon as you have an application or part of an application to measure, you can start understanding its impact on the device and addressing them earlier when they're certainly less expensive, as opposed to kind of an end of cycle. We've already got the app ready to release, and then we're just beginning to understand what its on-device performance looks like. Finally, and this really isn't from a technology perspective, it's more from a process perspective, but another challenge we see to mobile performance testing is the fact that a lot of these apps are built in an agile environment, an agile development environment. And what we really need to understand is how does performance testing fit? And we see a lot of situations where mobile performance testing or performance testing at all is just kind of gets pushed out of the agile cycle, or or just pushed to the end, kind of the old waterfall model where we're going to do this big bang system level performance test at the end of our development cycle. But we're really missing out on a lot of the benefits that the Agile development cycle offers in the first place. So I've got a handful of slides here that talks about some of our lessons learned in kind of shifting performance to the left and starting to understand performance testing earlier in the cycle, or I'm sorry, the performance characteristics of the app earlier in the cycle, where we have a better chance to address them. So one of the most important things from a performance testing perspective is that the Agile group needs to have a performance-focused culture. Non-functional requirements need to be captured, right? It's not just all about these functional user stories. Performance should be everyone's job, right? The old school performance testing center of excellence that all the systems kind of flow through at the end of their release cycle for their stamp of approval from a performance perspective, that just doesn't fit well with Agile. So if you're going to start thinking about performance early, it needs to be part of everyone's job. Even to the point where you may want a role to coordinate those performance-related activities that we're going to talk about in a few minutes. If you do have a performance testing center of excellence, you've got a lot of knowledge in that group that can serve as mentors to those Agile teams in terms of understanding, how do I understand user and load profile? What tools are available? How do I use them? How do I interpret results? One of the biggest roadblocks that we see is incorporating performance requirements, and there's a handful of ways that can be done. Acceptance criteria for user stories. We can have specific technical technical stories that are for developers only, and we can have them as constraints to our user stories. And typically what we've seen is that's how they're typically represented, as constraints to the user stories, because those constraints can then apply to multiple user stories, and we're not continuously documenting performance acceptance criteria in multiple user stories. From a shifting left perspective and getting performance earlier in the cycle, are we big bang system level performance tests at the end of every sprint? No, we're not, and it would be a disaster if we attempted that. But we can look at performance at a smaller level, unit performance testing, smaller chunks of the system, and even include performance testing in the CI chains. We'll talk a little bit about that as well. From a unit perspective, you probably have existing unit tests, and there are frameworks available, and I've got a couple links at the end of the presentation that allow you to decorate those unit tests with timers and with load. And are you executing these tests in a production-like environment? No, it may be the developer's desktop, so we're not concerned about absolute response times, but we're concerned about trends. So over each build, we're monitoring the performance of these unit tests, and if performance begins to depart from our trend, we know that that specific change caused an issue that we may want to investigate. And addressing that now, before the entire system is sold, again, is typically much more efficient. Beyond unit testing, right, starting to assemble components, understanding how the user stories map to those components so we know what we should be testing. Again, probably going to benchmark that in a development or QA environment, so we're looking for trends versus those absolute response times or other performance metrics. The entire system may not be assembled yet, so we can utilize service virtualization solutions for third-party or other components and services that aren't yet developed. certainly incorporate that activity as part of the continuous integration chain, and we'll look at that in a second. And finally, if we do start to create more traditional type performance testing scripts, we need to harden those scripts against application changes, making them less brittle, and we'll look at that we'll look at why in a second. From our experience with adding performance testing to the CI chain, we learned through the School of Hard Knocks that there's some things you need to think about. First of all, and very helpful, plugins exist for most performance test tools, so you can run performance tests as part of the CI chain. Once you're part of the CI chain, though, you need to be careful because organizations as a whole, get pretty mad when you unnecessarily break the build. You need to allow for the fact that you're probably not in a production-like environment. All right, so if you're setting failure criteria based on some performance metric, you need to understand that metric needs to be adjusted for the fact that you're not in a production environment. And they get really mad if you break the build but don't understand why, and that's really where that hardening comes in. Add error handling and logging to the script so you can quickly understand why they failed and either remove them or fix them versus spending a lot of cycles trying to understand why the build itself functions, but you're saying it failed from a performance perspective. So before we get to a handful of questions, I want to talk about key takeaways. And really, if we boil it down to these three differences, I think you've got a good start down the road of understanding why mobile performance testing is different and what you can do to address it. First of all, understand mobile users are not the same as connected users, and allow for those differences in your tests. And again, for those of us, and I'm certainly guilty of this, you don't want to treat your performance test as just looking at the back end and the network. Mobile devices get more and more powerful every day. There's still significant limits on them, and oftentimes that is where the user experience gets degraded. And finally, especially if you're an Agile development shop, think about ways to push performance to the left in that development cycle, and not just default back to the big bang end of life cycle performance test. All right, moving on to questions, and there's been some questions submitted. Over the chat window, so I will get to them here for you. And we're not going to have time. I don't think we said we'd be 45 minutes. We've got about 5 minutes left. But I will respond personally to all the questions submitted over the chat window if we don't get to yours, so rest assured that you will get a response. The first question is, why do I have to test with real devices? You don't necessarily have to generate your load with real devices, right? We use virtual users as part of our load test tools. But to understand the user experience when that system is under load, especially now that we have limits on those devices, it is important to include real devices as part of these load tests. They're more monitoring. You're not using them to generate load, but you're using them as monitoring tools to understand what that user will experience over that particular device and that particular set of network conditions. Does location that I'm driving load from around the world matter? I would say certainly it does. It does matter. Your users coming in from Asia or from Europe, if your data center is in the U.S., will have a different experience than those who are much more local to to the data center. And while certainly, right, if we wanted to go back to our old lab ways, we can use WAN emulation tools and appliances to approximate that. It's much more efficient, certainly, to use the cloud-based testing and distribute your users where they actually are, and versus trying to emulate that in a lab, especially if you have a high volume of users. The cost associated with that can be immense, and if you're not executing that test around the clock, it'd be very hard to justify those costs. This is a good question. How much overlap is there with my existing performance team expertise? I would say there's a fair amount. Quite a bit, actually. Certainly understanding what it means to plan and configure an effective performance test. Right? Where do I get the user and load profile information? How do I configure that? How do I account for that during execution? How do I use the tools? Right? Most of the tools that we've used our entire careers support mobile testing. Again, it's not all that different, right? So the tool knowledge is certainly transferable. The analytics. So right, an important skill for a performance tester is to understand how to interpret those results and what's meaningful and what's not. And from that standpoint, those skills are still very much relevant. Things that are new that'll have to be learned are more specific to mobile, such as the tools for measuring the on-device metrics, for simulating network virtualization if you haven't had to do that in the past, for understanding what services and options are out there for me to acquire my devices if I want to use a public or private cloud or things of that sort. If I want to incorporate an automated tool to drive my mobile app while I'm measuring. So there are definitely some new things that will have to come up the learning curve, but really that's been the case probably throughout all our careers. We've had to adjust and pick up new things as we go. But the number of things that transfer over to mobile is significant. And we're certainly not looking at a completely separate set of resources or separate set of skills that we have to be successful with mobile performance testing. So it looks like we're at the end of our time. I want to thank everyone again for joining. Again, there's quite a few questions that were not answered live. We will get to those responses via email within the next 24 hours. And if there's any additional questions, you've got my contact information. Please feel free to reach out directly to me, and I'd be glad to have a discussion or answer any further questions that come up. So thank you again, everyone, for joining, and have a good rest of the day.